All right, so let's start simple. What is on-chain orchestration? At a very basic level, orchestration just means coordinating multiple smart contracts to achieve a single goal. So you guys can think of it in a way that uh, a smart contract is a tool, and many contracts together create a workflow. Orchestration is just the idea that logic is just the idea of logic connecting everything, all these tools, all these smart contracts to create that workflow. Uh, if you think about it from a traditional sense, uh, in traditional apps, you'd usually have a backend server coordinating all these tasks, all these tools. But on Ethereum, the blockchain itself, Ethereum itself becomes the coordinator. Right? By the way, throughout the session, if anyone has any doubts, just feel free to unmute yourself or drop your doubts in the chat. Okay. Great. All right. So let's start with a very simple example. I'll put up to Xcali, and let's say we have a situation. Hold on. Okay. Let's say we have a situation where we wanna. So then let's say, great. Okay. Let's say we have a situation where we want to borrow funds. Then let's say we want to swap them. Then let's say we want to provide liquidity somewhere, and then stake the LP tokens for it. So let's say we have these 4 steps that we want to do, right? Normally, what you would do is you would go to 4 different protocols and you would do these steps manually one by one. This is not really efficient when you're talking about automated systems, or if you need something like this inside your smart contracts. So what do? You build an orchestrated system for them. You want to have a scenario. Let me put this in a box. Can't give this to okay. So let's say you have now the scenario that you're faced with is that you have to do all 4 of these tasks in a single transaction. So in a single transaction, you guys want to make sure that you end up performing all 4 of these tasks without manually going to 4 protocols and doing 4 of these steps. One really important thing that you would also want when you're performing these tasks in a single transaction is that uh, either all steps succeed or everything fails. So you wouldn't want your transaction, or let's say your workflow, to borrow funds, swap them, but then fail at providing liquidity, fail at staking the LP tokens because, of course, you didn't provide liquidity, and your entire transaction is just half complete. You wouldn't want that because it breaks the flow of your orchestration. So a really important property that you need to keep in mind is atomicity. Yeah. So atomicity ensures that the single transaction that is happening from the user for all 4 of these steps, either all of these steps happen or none of these steps happen, all of them revert. This ensures that there's no half completed mess when we're working in an orchestrated system, because usually every step in an orchestrated system, so let's say step A, step B, step C, step D, each other step usually builds upon the step before. And for that to happen, you want all of those steps to happen correctly, sequentially, and also happen in a way that the previous step executes correctly for the next step to succeed. So you want to make sure that atomicity is preserved in your transaction. So how do we do this? How do we ensure that this happens? So what you can do is the user interacts with a smart contract, we'll call this orchestrator contract. Let's make it a little bigger. Okay. Right. So the user interacts with the orchestrator contract, and the orchestrator contract has the workflow or the orchestration defined for your smart contract system. So let's say the orchestrator contract can go and borrow from Aave. The smart contract can then go and swap. Smart contract can then go and provide liquidity, and then the smart contract can go and stake the LP tokens. So we have a question. Let me see. All right. So all of these things can be orchestrated with an orchestrator contract. In that contract, you basically define and call. Let's say I'll write a very pseudocode example. So let's say you have a function called orchestrate, takes in some params and returns, let's say, a Boolean value. And your orchestration function can call borrow, it can call swap, it can call pro liquidity, and it can call stake. Now, from the user perspective, the user just calls this one function, orchestrate. Inside the orchestrate function, you call these four functions. And if any of these four functions fail, your orchestrate function reverts, meaning that none of these all the functions that came before the failing function will also revert. Essentially, this entire thing becomes a no. So this ensures that atomicity is preserved in your orchestration, and that a user does not have to manually go and make four transactions to do all four of these steps. So this orchestrator contract is what you usually use to orchestrate different parts on chain. So yep, I think I'll ask if everyone understood what we're talking about so far. Do we have any doubts? Any doubts? Any questions so far, guys?
So I have a question. Hello, I have a question. So are you trying to say that instead of maybe you have a particular smart contract on that has the swap, the borrow function, like in like you have the swap borrow function and other functions. So are you trying to say now that a point of entry, a user point of entry can be that orchestration function that calls those functions from that orchestration function? That's what you're trying to say. So like literally, a user point of entry is not your contract, it's more of that orchestration function.
Exactly. So your point of entry would be this orchestration function, and then this orchestration function will then call all these different contracts or all these different functions on different protocols. So for the user,
but what if, sorry, what if you want to just call one of it, just want to call borrow?
Yeah. Oh, then you just directly call borrow. So in your smart contract, maybe usually what you do is you build a wrapper function. So you define, let's say, function borrow, and let's say some XYZ. And then inside this function, you call the underlying borrow function from another contract, and you basically define all your uh, let's say all your values. So let's say the contract uh, address for which you're calling on which you're calling this function on, and let's say if you have any parameters or if you have any, let's say, prerequisite calls to call this borrow function. So when if you just want to call a single function, let's say just borrow, you usually just build a wrapper contract. And but when you're doing orchestration, I think what you can do is you can build four of these functions. So let's say one for borrow, one for swap, one for providing liquidity, and one for staking. And then you just call these four. So let's say borrow XYZ first. Then if you build a wrapper function for swaps, so swap XYZ, and liquidity XYZ, and then stake XYZ. So normally a good pattern to follow when you're writing or when you're calling functions from another contract or another protocol is to build a wrapper function around them that aligns with your own contract and your own protocol. So the point of entry is the orchestrate function. Uh, it calls other functions inside your contract or outside your contract. If it's inside your contract, you can just if it's an internal function, you can just call it normally. So you can just call borrow. If you're calling a contract from if you're calling a function from another contract, then you usually a good pattern to follow is to build a wrapper function around that a function, and then call it inside your orchestration function. Does that answer your question?
Okay, if you want, assuming now if I want to call a swap function on Uniswap, it's better I should do it through an orchestration.
Yeah. So you usually use orchestration or the idea of orchestration when you want to chain multiple different DeFi actions or actions in general together. If you just want to call, let's say, swap on Uniswap, then Uniswap has a router contract, and this you can simply let's say you have your own contract over here, then you can just call this router contract from your contract, and this router contract then handles what happens with that function. Oops. Okay. Then this router contract handles what happens to your function call. Essentially, if you look at the router contract code base, the router contract in itself acts as an orchestrator. I'll give you a very good example for this. So yeah, so the router contract that Uniswap has itself acts as an orchestrator because it decides where your function call actually goes. It decides if your different actions needs to be changed together. So let's say when you're calling the swap, let's say you're calling the swap function on Uniswap. Under the hood, it requires three or four different checks or different functions to be called first. Then the underlying low level underscore swap function is called in Uniswap. So it's basically ensuring that okay, all four of these functions will be called for the swap to go ahead without any issues. And if any of those checks or any of those functions fail throughout the entire process, we essentially revert the swap. So the router contract that Uniswap has is also like a really, really good example of orchestration. Yeah, does that answer it?
Yeah, so that Uniswap router acts like an orchestration.
Yeah, yeah. Why not we just look at the example on the universal router Uniswap. And just to give you guys, and this is something I was going to talk about further into the session, but an orchestrator contract is, or orchestration in general, is not just about calling different functions on different protocols or different contracts. It's also making sure that you route the correct logic to the correct function or the correct contract. So instead of, let's say, calling 4 functions, or let's say doing 4 of these actions, the orchestration contract, the orchestration contract, it can, based on, let's say, I call an orchestrate function, let's say in this case, and our parameters can be, let's say, xxx, xxy, xxz, and so on and so forth. So based on what the parameters are, your orchestration function can decide, oh, this is the function that I want to call, or this is the function that I want to call, or this is the function that I want to call. So routing is also a really, really good form of orchestration. So a really good example that I can show you guys right now is the universal router contract. Let's look at the code for this. Contract and universal router. All right. So if you look at the universal router contract, it has some functions called execute. It has a function for execute sign. And you know what? I think the README probably has an example. Yeah. Okay, great. So the universal router and Uniswap has something called command encoding. So based on the parameters you give it, based on the parameters you give to the Uniswap router dot execute, the execute function that I just showed you guys, it decides which swap do we actually want to execute. So let's say the command is 0x00. Then it goes to Uniswap v3 and calls the swap exact in function. If we do 0x01, then it goes to Uniswap v3 swap exact out. And in this way, the universal router can allow you to route to Uniswap v3, Uniswap v2, specific functions inside those protocols, Uniswap v4 as well. It's not updated over here, but it also routes to Uniswap v4. It also allows you to wrap or unwrap ETH, and so on and so forth. So the universal router contract can, or orchestration in general, routing in general is also a really, really good form of orchestration, like we see in the case of the universal router by Uniswap. Orchestrated contract is CCI. So can you just drop what CCI is? First mention is flash one, which says 0.04% rate, and then mentions on the orchestrated stack is a reversion here. So then does the flash one percent is created provider, and how does that work for the provider to get its due percentage? So when you're doing a single transaction, right? It essentially reverts the so this is a really nice conversation that we had at Blok Capital a while ago as well. That, let's say, and here's a simpler example of here. Let's say we call the swap function, and then let's say we call the swap function, and then let's say the token out from this swap call is then been used to provide liquidity somewhere, right? Now, let's say if providing liquidity fails, what happens to the tokens that we got from the swapper? So Ethereum, what basically Ethereum does is that whenever, okay, so one second. Okay, so whenever on Ethereum, whenever a transaction comes in, a single transaction in itself can contain multiple transactions. If a single transaction throughout that fails, it reverts. Right now, any action that has happened, before that transaction that reverts, they're all reverted. So until this transaction completes, the token out that you get from that swap function hasn't exactly been processed yet, right? It's in an intermediary state until this entire flow of transactions complete. So let's say if provide liquidity fails, then token out is also reverted and the swap call is reverted as a whole. For if the entire transaction that encompasses these two actions. Until these two actions don't complete perfectly, then the token out in itself gets reverted. So swap didn't actually complete in it as a whole. It gave you a value for the token out. You give that to provide liquidity, and if provide liquidity fails, then yeah, basically the funds just go back. It's a single transaction. So the state change that happened in the Ethereum VM, it just reverts. There's no actual state change that's happening. So the swap doesn't actually give you like execute a token out because there's no state change happening inside the virtual machine. Does that make sense? I think the presidential only no rewards happened in the chain transactions. I think the presidential interest is only paid if no rewards happen in the chain. Yeah, yeah. It also had to be some. Yeah, true. So basically, the idea is that if you look at Ethereum closely, whenever a transaction happens, it changes the state through something called the state transition function. So the state transition function only changes when a transaction comes in or when a successful transaction has happened. In this case, no transaction has been successfully happened yet. So the swap in itself, so no account state has been updated. So it's not like the manual steps that you do. Okay, you do swap, you get tokens in account, and then you use those tokens to provide liquidity. It's not like that. Uh, it's basically instead of these two transactions separately, it's just a single transaction, and that single transaction, if it completes, it changes the state altogether. If it doesn't complete, it does not change the state at all. Does that answer your question? I think it does. Yeah. Okay. Any other questions, guys? This is a pretty good question, by the way. The both of the guys that asked questions, so pretty good. Yeah. Any other questions? If not, we're gonna move forward with uh, orchestration. All right, great, awesome. Yep, keep asking questions, guys. It's nice. Yeah. All right. So now we're going to look at why on-chain orchestration actually matters. You guys might be thinking, why should we care? Why, why not just go with our lives without knowing what on-chain orchestration means? So there are four major points. We're going to go through them one by one. Trust minimization is a huge thing. You don't want a backend server, or you don't want non-atomicity in your transactions or in your orchestration. A lot of protocols that still do this is that they will have a backend server running, which will orchestrate things for you. Which although is gas efficient, not that it matters now with gas imploding so much on L1. But earlier, something that happened a lot was people would have backend servers that would call, 4 or 5 different transactions separately instead of having one single smart contract and making that smart contract orchestrate. So if that single backend server went down, so did the protocol with it. So orchestration should be on chain for this season, is that you don't need a centralized coordinator, you don't want a middleman, you don't want a backend server. Everything should be transparent, it should be verifiable, and should be immutable. At no point should your protocol fail because your orchestration was happening in a way that it was prone to failure. So trust minimization is a huge thing when it comes to on-chain orchestration. Then composability. Now, imagine Ethereum like Lego. Uh, on Ethereum, you can think of each protocol as a block, and orchestration is this idea of snapping all of these blocks together. So you guys can think of your own ideas or your own orchestration protocols are basically just snapping all these different Legos together, all these different protocols together to build a really nice set. And now this allows you to essentially, okay, 1 second. Okay. So this allows you to essentially bridge multiple multi-step operations that are really, really complicated into single transactions. And that brings us to atomic execution. This is a huge thing for Ethereum because everything happens in one transaction. If anything breaks, the entire thing reverts. And this is exactly why things like flash loans work. So the last point, automation without custody. You can automate entire strategies without holding user funds, and that's pretty powerful. And if you look at trustless bots and autonomous systems, they work exactly like this through on-chain orchestration. So I have one question. An orchestration function is used to chain different calls in one call from user's POV. But do we have to write all the possibilities of such transactions? Like if someone wants to call borrow first, then deposit, and vice versa, for example. So usually, let's say you would have a fixed flow of things according to your protocol. Let's say you want the user, or let's say your protocol provides a for investment or uh, for investment or for, let's say, trading, right? You're providing a trading strategy to your users. Now your trading strategy follows certain rules that, oh, first I'm going to go borrow, then I'm going to go and uh, stake, lend, etc., etc. So in that case, you need to have things in an order, and then you orchestrate according to them. The other option that you want is that uh, the user should have the possibility to put other things first. Let's say if they want to deposit first, or if they want to borrow first. So in that case, you can use a pattern similar to the Uniswap universal router that I showed you. In that case, you can manipulate this using the user parameters. So depending on how the parameters are called, you can decide, okay, this function should be called first, and then so it's a simple if and else statement. So you can be like, okay, if okay, let me show. I'll just write it down. Just some pseudocode for you guys. So let's say if okay, let's start with orchestrate function again. So let's say you have a function orchestrate, and let's say it takes a bool inside it, and this function can essentially check if bool, then this essentially means if the boolean is true, then I can just, let's say, borrow, and then uh, deposit, or let's say lend, or let's say swap. I think that would be a better example. And else, oops, I missed my code editor for this, but yeah, okay. And then swap, and then bot. So what this essentially does is that whenever someone calls your orchestrate function, they can either pass they can pass a boolean value, so true or false. If they pass true, then borrow, then swap. If they pass false, then swap and borrow. So it's like a simple control flow statement, and in that way you can have different flavors for your orchestration. uh, this cannot be a boolean as well. It can be something similar to the Uniswap router. It can be bits, so 0x00, 0x01, 0x02, and depending on that, you can have like switch case statements that, oh, if this comes in, what do I want to do? What do I want to execute? How should my orchestration look like? So you can customize it however you want. Yeah, it's up to you. The orchestration is initiated by the user. So the order keeps changing as per the user intention. So on protocol level, orchestration ensures that whatever user intended flow happens as automatically. Yeah. Smart contracts cannot invoke themselves automatically. Uh, a smart contract itself, let's say just the orchestrator contract. The orchestrator contract cannot have something like a cron job that triggers every, let's say, 5 minutes. That, oh, every 5 minutes I'm going to call my own orchestration function, right? So some external entity, in our case the user needs to trigger a function for all of these steps to happen. So the user can maybe have an off-chain thing if they want to trigger it every 5 seconds, every 5 minutes, or better yet, where Aditya, who's going to be taking uh, off-chain orchestration up after me, is going to be talking about how truly autonomous systems without any user interference can work with orchestration. So yeah, keeps yeah. On the protocol level, Ethereum itself ensures that whatever happens, it follows atomicity. Okay. Can it be great if you could drop it on Discord or here if you wanna continue? Yeah. Yeah, we're gonna be talking about CRE today, Daniel. Yeah, some keep. Yeah, so usually, further in a bit when Aditya takes over, he's going to be talking about CRE, cron jobs, and how a safe off-chain service can be used to continuously call the contract every few seconds or every few minutes, depending on how you want to customize it. So, yeah, that's something that's Aditya going to take up in a bit. Great, great. All right. Do you guys want to continue, or do we have any other questions before we go further? Nope. All right. Great. Okay. So let's talk about the key building blocks when it comes to orchestration. Uh, like things that actually make this possible. This is intuitive thing. So yeah, follow along. Keep keep your minds open. And yeah, let's talk about it. So, smart contracts in an orchestration, you can have as many as you want. You can have as many modules, as many smart contracts having different functions defined, and you can have as many of those as you want. They're basically the building blocks for your entire orchestrated system. These can be smart contracts. These can be different functions. You would preferably break them into smart contracts into different modules. These can be entire protocols as well, right? Uh, External calls are the way you actually interact with these different protocols, with these different contracts. So you either use call, you can also use delegate call. I hope you guys remember delegate call from the last session that I took about diamonds and facets. So delegate call is how the diamond routes to the facet. So yeah, either that or through interfaces. Transactions are basically the container that run everything. A single transaction can trigger multiple contracts, and it should all follow atomicity. That's something that I'm stressing out a lot because entire orchestration is based on atomicity. And events and logs are pretty important when it comes to coordinating things off chain. So again, that's something that Aditya is going to take up deeper further. But events and logs for you when you're performing on-chain orchestration is pretty important as well to ensure or to find out points where your orchestration might not be performing its best in terms of performance, in terms of failing, reverting. So events and logs are really important in your orchestrated system. And then your orchestrator contract. These contracts are specialized. They are meant to manage the entire execution flow of your protocol. So this is like a key building block inside your orchestrated system. Now, do you have any questions? Okay, in production systems, how do you balance between indexers like Ponder and direct RPC calls when building a real-time protocol orchestration. Well, usually in these cases, you can't really rely completely on on-chain orchestration. In these cases, you would need an off-chain service that's keeping track of it on real time. You usually use a real-time RPC, so something like a WebSocket RPC. But yeah, on-chain orchestration isn't the best way to go about, you know, indexers or like that real-time protocol orchestration. These are mainly for chaining together different tasks. So again, like strategies, like sequential steps, or let's say based on conditions. Like we had a question before. Yeah, this one. So based on conditions, or just breaking down different modular parts into different pipelines. So whenever you're talking about real time, or whenever you're talking about performant orchestration, then you need an off-chain party to simulate or orchestrate that. Now, how do you do it securely? How do you do it reliably? Is something is done through something called CRE, and yeah, Aditya will go over it with you guys in a bit. Oops. Okay, so we're going to learn about some core orchestration patterns. So the first one is sequential. Let me go back to Scali. Was this okay? So sequential is something like I showed you guys over here. Oops. Yeah, it's basically performing step one, step two, step three, step four. And yeah, it's pretty straightforward. You basically call different functions or different protocols one by one, and you basically chain them together. Another is conditional logic. Like I said, I would be talking about this further, is this one. So orchestrating based on conditions. So it can be something like, okay, if price drops, then liquidate and fund it again. Or better yet, in this example, if if this boolean is true, then borrow, then swap, else swap over. So based on conditions, you can have different orchestrated systems, or you can break things into different reusable pieces. So let's say this uh, borrow from away, this requires multiple functions to be called, multiple checks to happen, multiple functions to verify that okay, uh, borrow is ready to be called. Now you can simply make an entire contract called, let's say, away, or let's say in our case borrow module. Let's not use away for now. Borrow module. This borrow module has all the different checks, all the different let's say pieces that you need to actually borrow. So whenever borrow module is called, just inside this borrow module, you are having like 4 or 5 function calls, and then inside swap, let's say if you build a swap module, the swap module does the same thing in calling multiple functions to ensure that okay, swap is ready. Same for providing liquidity, same for staking LPDO. So this is more of a really nice pattern to keep in mind, to basically split different, or let's say split specific logic into different contracts as modules, so that when the orchestrator calls them, it just calls those functions or calls a very high level function, and the module itself handles all the verification or handles all the checks, and then just performs this work for you. Do we have a question? Okay. All right. So the next one, okay, we talked about sequential, we talked about conditional, and yeah, we talked about modules. Okay, now delegate call. So from one of our previous sessions about facets and diamonds, uh, we had a diamond and we had multiple facets for the diamond. So let's say we're going to go with 2. Now this is also in a way a very good example of orchestration. Basically, you can run code, or basically the diamond in itself can be a router for both of these facets. So based on the call that we get, based on the function selector that we get from the user's call, the diamond can route it to either facet A or facet B. This is also a very good example of orchestration, and this happens through something called delegate call. So I hope delegate call is something that you guys still remember, or do you guys want me to go over it again? You guys remember? Can anybody, you know, unmute and talk about what delegate call is, or just write it in the chat so that we know that, we still have that thing in our mind? Anyone?
Delegate call is the call when made from a contract that
Mhm.
changes its own state and not the contract being called.
Mhm. Yep. True. So, yeah, it's basically you execute logic from another contract while being in the context of your current contract. So yeah, awesome, great that you guys still remember, and that is pretty bullish, pretty nice. All right, so we've looked at four patterns so far. We've looked at sequential, we've looked at conditional based orchestration, we've looked at module based orchestration, and we've looked at delegate call. These four are the major patterns that we see in orchestration. Another one is batched execution, but that is closely tied with atomicity. So as long as one transaction can perform many executions or many actions, that's what we call batched execution. And it is closely tied with all of these different orchestration patterns. So great. Now we're going to look at some real world use cases uh, for orchestration. So we're going to start with a simple example. It's about flash loan arbitrage. So imagine this: ETH is cheaper on one DEX, but it's more expensive on another, right? So you borrow funds, you buy cheap, you sell expensive, you repay the loan, and keep the profit all in a single transaction. How is that? So all of these different steps that are, part of this flash loan arbitrage. So first you go, you borrow funds, then you go and buy Ethereum from cheap on one DEX, you sell it on the expensive one, then you repay the loan from repay the loan that you took, and then and yeah, you keep the profit. You do all of these things in a single transaction. How is it possible? It is possible through orchestration. So let's just go through a small diagram with this. So and say flash loan. In this flash loan, let's say you take a flash loan, you buy ETH on DEX A for cheap, you sell ETH on DEX B, and you repay this loan. And this is a very good example of arbitraging through flash loans. This is something that happens, although it's been reduced a lot with DEXs having very similar prices for ETH. But yeah, basically you can flash loan arbitrage, and usually bots pick this up faster than anyone. So it's pretty hard for people to do it. But yeah, so basically you can have this loop. You get like a minimal 0.00 something profit. But yeah, this is something known as flash loan arbitrage, and it's widely done through orchestration. Do you have a doubt? Okay. Any doubts so far, guys, by the way? This is like we're talking about examples and real world use cases of orchestration right now. So these are some examples that are actually happening and that you'll actually see in systems today. So yeah, it's no doubt. Okay, moving forward, a really good example can be DeFi aggregators. So the current examples that I've been giving you guys about, let's say, borrow, lend, swap, uh, and let's say provide liquidity, uh, they are all examples of DeFi aggregators. So if you look at swap aggregators or like DEX aggregators, they don't just swap once. They split your trade. They route across like different multiple dexes on that chain, and they optimize for the best price. That is orchestration. You're basically getting quotes from all these different dexes. So let's say you you have a dex aggregator. It This dex aggregator. Let's see. 1, 2, and 3. Okay. This dex aggregator goes to dex A, it goes to dex B, it goes to dex C, and let's say the user, let's say the user comes in and the user says, "Oh, I want to swap 100 USDC to ETH." So, uh, yeah. So let's say the user comes in and the user says that, "Oh, I want to swap 100 USDC to ETH." Now, what the DEX aggregator would do is it will go to DEX A, it will ask the DEX A for a quote. It will go to DEX B, it will ask for DEX B for a quote. Go to DEX C and it will ask DEX C for a quote. All of these quotes come inside the DEX aggregator. The DEX aggregator checks for max between, let's say, quote 1, quote 2, quote 3, and whichever one has the highest quote, let's say in our case Q2, or let's say DEX B has the highest one, then the DEX aggregator basically calls this swap function for the user on DEX B, essentially swapping this 100 USDC for ETH and then giving the most optimal price for the user to execute his swap. So all the DEX aggregator in this case acts as our orchestrator contract. It orchestrates between 3 different protocols to find the best price and execute a swap on the best one, on the most optimal one. Orchestrator contract. Yeah. So this is a pretty good example of DeFi orchestration. So yeah, to this we have like many examples. So yeah, to this like we have many examples for DeFi aggregators. In this way, if you talk about DAOs, in voting also you can have many different examples of orchestration and automation. Yield vaults, you deposit once, but behind the scenes you can maybe have your funds moving across different strategies. Rewards are harvested, your positions are rebalanced. All of these happen through orchestration, and basically all in DeFi and beyond. In most modern on-chain systems, you use orchestration in one way or another. It's very important to follow certain patterns of atomicity of let's say just simply wrapping your contract or splitting your contract into modules. All of these patterns are really important when you're designing your own orchestrated system, which you probably will, considering the protocols that are coming up and the protocols people are designing in today's world. So let's talk about a few challenges and risks that come with orchestration and that come with automation. So gas gets pretty expensive pretty fast, like the example that I showed you guys before. Although now it's not a huge problem. On Ethereum mainnet, maybe a bit. On L2s, not really. But gas gets pretty expensive pretty fast the more complicated your orchestration is. Let's say you have 100 different contract calls inside a single orchestrate function. That would, you know, a single orchestrate function call in that case would result in the gas cost of 100 different transactions, and that is not really optimized. So, what I said for the off-chain execution part. Sometimes you do need off-chain orchestration, and that's something that we'll discuss in a bit. Uh, More calls also equal more risk, because you're relying on the security of these different protocols. So the more calls, the more contract calls that you get, it also creates a higher attack surface. So it's important that the protocols, the smart contracts that you use in your orchestration, they're all properly vetted. They're you basically trust them, the community trusts them, and you're sure that okay, these protocols are not malicious, or that these protocols don't make your orchestrated system vulnerable to attacks. So basically, if like one protocol breaks, everything in your orchestration breaks. Debugging is particularly very painful when it comes to orchestrated systems. So it's hard to trace. It's very hard to audit. That's why when I was talking about the building blocks for orchestration is to have proper events and logging inside your contracts. This greatly helps in reducing your time to debug certain errors or certain complexities that come while development. So make sure you and most people overlook adding events, but it's pretty important to ensure that you guys have proper events, proper logging for your smart contracts and orchestrated system. And last but not least, probably like one of the biggest challenges when it comes to orchestrated systems is MEV. So for larger attacks or for larger transactions, MEV bots might attack your funds or your transactions. So very complex orchestrations are very prone to MEV. So they can be front run, they can be sandwiched. But we have really good solutions. So we have protocols like Angstrom for swapping. You can use private RPCs. You can use private mempools, flashbots. So we have a few mitigated steps for it, but still MEV for uh, cross-chain orchestration or for orchestration through most protocols is a huge risk when it comes to bigger DeFi actions. So, any doubts so far? Any doubts? No? All right, great. So, what does the future of on-chain orchestration look like? Where are we headed when it comes to orchestration? Is that users now won't be defining steps anymore. Like the user won't be saying that, oh, swap, lend, borrow, etc. They'll do something, or they'll provide something called an intent, right? So intent-based systems are something that's widely coming up inside Ethereum. The user just specifies that swap ETH to USDC at the best price, and the orchestrator contract handles that. Oh, I want to use a DEX aggregator right now, and yeah, my DEX aggregator is meant to swap ETH to USDC at the best price. So understanding user intent is very important. Now that more AI-based user-friendly systems are coming up. Uh, AI agents could now run strategies for you. So ERC 8004, which is about trustless agents, can now also run orchestration and strategies fully autonomously and on-chain for you. That's something that's been coming up a lot with OpenClaw, with your own, with people having personalized agents running now. Cross-chain orchestration is a very hot topic. Basically, how do you coordinate actions between different chains? Usually, you do it through a message passing protocol like CCIP, like Wormhole, or the messaging layer that Circle uses for CCTP. So you have a few messaging layers across different chains, but this will also widely change as Ethereum moves towards ZK VMs and proof traces. So cross-chain orchestration is something that's been widely used right now, but there's like huge scope to improve it, and there's a huge scope on what Ethereum is working on right now that will change cross-chain orchestration further down the road. And modular execution layers are something that's really important, and that is something that's coming up a lot. And it's something that we at Blok Capital are also trying to keep in mind in our architecture. Modern protocols, some protocols have started using a singleton architecture. Let's say Uniswap V4. It's basically your pool manager contract, single contract that holds most of your logic. Uh, but again, you would always prefer a modular architecture over it, because you want execution logic and to be different from your scalable logic. So basically, you want some part of your infrastructure to be upgradable. You want some part of it to be, fully immutable. But you also want to make sure that the interaction between these two layers is modular. It is orchestrated well. So yeah, modular execution layers are something that's pretty important as well. And yeah, that's pretty much all that I want to discuss about on-chain orchestration on Ethereum. So yeah, orchestration is basically, what's been turning Ethereum from just a collection of smart contracts into a system of systems. So if you're building in this space, if you're building in on the protocol side, this is not optional knowledge at all. It's core to what every protocol is doing in Ethereum, and yeah, it's pretty important for anyone that's looking to be a protocol builder. Thank you guys for listening. And do we have any questions before I hand it over to Aditya? Any questions, guys? Great. All right. Thank you. Awesome. So now, Aditya is going to take over and talk about some really amazing things on off-chain orchestration, how we can do it safely, how that works with CRE. And yeah, I'll hand it over to Aditya to explain how that works.
Yeah, uh, thank you, Vansh. I'm audible, guys. I'll just share my screen. Just a second. Hope the screen is visible. Yeah. Yep. So hi, I'm Aditya. I'm a developer at Blok Capital. So Vansh has given us a very great session on orchestration, from concepts to the function and function levels. Today, let's dive more into CRE, a framework powered by Chainlink, basically for orchestration and overall automation, for multi-chain especially. So let's dive in. Before that, I just want to let you guys know that we will be starting from off-chain systems, basically how today's off-chain systems work, what are their limitations, and we'll, once has explained about MEVs and flashbots a lot. So that topic is very relatable to orchestration, because MEVs are something that pose a problem today, and they can be solved through orchestration also. So I'll be also explaining a real based scenario, which I have worked on, and yeah, it will just bridge you guys to in the CRE mode like completely. So let's start. Yeah, we'll just get a walkthrough like what I'll explain today. We'll basically understand the off-chain ecosystem in 2026, like today. Why do we need a framework like CRE at all? Like, why a single framework can, solve a lot of problems today. Then we'll discuss the basic core architecture of CRE, the off-chain part, the SDK part, and later on we'll see different Oracle and different integrations or protocol integrations in CRE, and how CRE is compatible with all of them. And then we'll just move towards the SDKs, and I'll just walk you through the how the general setup is done through a code base. Yeah, that will be the last part. So let's move. Uh, yeah, so today's off-chain 26. Basically, apart from CRE launched, I guess, like in September or October in 2025. So it's been like 6 to 7 months now. And before that, we had different services like Chainlink automation, Gelato, uh, the cross-chain messaging protocols like CCIP, CCTP, Layer Zero, which eventually worked with orchestration parallelly. And obviously those ecosystems or those protocols had their own limitations. Like Chainlink automation was completely based on automation part, triggering part. um, it didn't did well with the multi-chain part. Like there were like a lot of complexities to build Chainlink automation around multiple chains at the same time. Gelato also, like it's Gelato is not multi-chain again, so yeah, that was the limitation with Gelato. Other cross-chain protocols like CCIP, those were just mere messaging layers. They didn't. We can't call them pure orchestrators. Like you guys already know what orchestration is. Once has explained it like at the very basic level, and CCIP, CCTP are just messaging layers. They do not contribute in orchestration at all. So eventually in 2026, since protocols are like, especially off-chain ecosystem is growing like at a very large scale. Trust minimization, trustlessness is growing at a very large scale. So we definitely need a particular framework, a single umbrella framework, which will manage all this, like which can, go more advanced in terms of oracles, APIs, triggers, automations, toolkits, and frameworks. So let's build this idea with a certain scenario of MEB optimizer. I have worked on it in with respect to CRE. Also, I have integrated CRE with this concept, and I'll walk you through my research, like what I feel around MEBs and basic flashbots and private mempools, which once was talking. How we can take all those scenarios in mind, and we can discuss how CRE can do the heavy lifting around these concepts. So just for an example, let's we all know that MEV optimizer, MEV engines, and MEV pipelines are all off chain. Like they do a ton of computation. They solve a lot of complexities through a lot of execution environments, like total sandboxing environments, and these are all possible only via off-chain environment. This cannot be done completely on-chain. So this particular instance can be discussed with the context of CRE. So yeah, um, let's move. Recently, I also want to discuss like Aave have their own liquidation engines, which kind of extracts a lot of which optimizes MVB around its own protocol like a wrapper. But again, they are failing at their own scale. Recent Aave liquidation scenario, you all know that it failed drastically, right? So somewhere around liquidations, the off-chain components are failing, and I think that's the reason some framework should jump in, and we should all contribute around that framework. So yeah, let's understand the detailed scenario. Most DeFi lending protocols liquidation opportunities become visible in the public meme pool. So for you guys, I've just made a clear diagram around this scenario. Yeah, so suppose like I'll just bridge you guys how CRE will come into play here. So this is a general MEV scenario where a lot of searchers and liquidators basically are traversing through public meme pools around L1s to check whether liquidation positions are open, and if the transactions are rolling. So they could certainly catch some transaction and front run them or back run them. Back run in the sense that some oracles are open from for their price feed updates. So yeah, like basic attacks, right? So what this concept stands is like, public meme pools are transparent, right? Anyone can see it. And the only problem here was that a lot of executors were rushing in the meme pool and rolling out the transactions, increasing the gas price. Overall gas price was a little spiking, the ecosystem around the gas ecosystem was like drastically falling apart. So uh, researchers have, you know come up with an idea that instead of public meme pools, what we can do is we can arrange some private meme pools or private auctions, so that the gas price leakage won't happen. And this control strategy should be, evolving around Ethereum also. There were like various drafts around Ethereum that these control strategies are to be, made public, and work has to be done on it. So that's exactly where some orchestration framework like CRE can help to establish that trustlessness, the auction price following the auction house. Basically, that concept is called as auction house. So like various white papers have included those concepts around MEV extraction possibilities around the protocols. So you can think how CRE comes into play, right? This was the like very real world scenario which Vansh has also explained you guys. But this is like a diagrammatic or a visual expression about how MEVs were actually transferring, like how extraction was actually happening. So yeah, if you guys are tuning in, right? Any doubts? Okay. So we'll move forward. Yeah. So let's discuss, like, again, let's revisualize everything, and let's see like why do we actually need a dedicated framework, right? um, Again, like different off-chain machines have very sophisticated pipelines, which are not, like if you generally observe various off-chain uh, projects like around Aave or Morpho or any other DeFi protocol, they are not public, right? They are always private. So even now, Aave has its all off-chain heavy lifting done privately. It's not public yet. So I think the first thing we should discuss is like a protocol like CRE, which is which can be completely transparent. Because it involves on-chain verification at the same time with the validation part in itself. So basically, the first advantage of CRE is that off-chain executions will be transparent for any user to visualize and see what's actually happening under the hood. Those sophisticated off-chain machines are like now visible for you guys to, verify anything. Like there is just the function verify, which you can use, which you guys can use any public key to verify any transaction that's validated by the off-chain component. And yes, all that happens in basically the CRE. So CRE has an upper hand in all that things. Again, moving further, we are dealing with smart contracts that locks worth assets worth billions. Yeah, right. So these institutional players always have a lot of like thick liquidity around the protocol. So this has to be dealt with very care and very risk minimized way. And I think in further discussions of CRE architecture, we will be seeing why CRE is like very uh, productive in these particular instances, because the SDK itself is, developed by the Chainlink, which is an institutional player from decades. And the way it has been developed is like there is almost validated by the network of nodes at every iteration and at every handler. So what are handlers and what are execution pipelines, that will further discuss in the core architecture, don't worry. I just want you guys to understand the reason why we are hosting CRE session rather than any other off-chain service, because it definitely has a advantage over all those protocols today. Yeah. So as I said, large institutions usually develop their own in-house services, like Aave develop their liquidation services, which is completely off-chain. Uh, but to cater the requirements, this doesn't provide them plug and play type of agreement and work compatibility with other domains of the same project. What this means is the pluggable thing, like various projects like Aave and Morpho, what they do is they don't they especially rely on third party providers like the off-chain labs. Suppose Aave as a protocol depends on off-chain labs for risk management. Off-chain labs is paid by Aave. It is completely off-chain service maintained by off-chain labs, and their product is basically in the risk management risk management module of Aave, where which usually deals around liquidations. So this is very perfect example like why Aave doesn't do their in-house development, because they trust other protocols to manage the liquidity, the risk, and the control over their protocol. So this gives an advantage to some frameworks like CRE, which different projects can integrate CRE to build some modules, maybe the build some risk modules, or develop a module that can be handed over to any DeFi protocol for their risk management. So yeah, from development perspective also, it is like win-win situation for CRE. If you engage with CRE today, it's like the DeFi needs it, like, definitely. So yeah, that is the uh, one of the reasons. Yeah, like these were the core reasons that we need a dedicated framework for DeFi, especially because DeFi as a machine is very complex at all, and we today still believe that a lot of people don't understand DeFi uh, at at the level like how complex it is. And some the projects like CRE can work under the hood, do some heavy lifting, and really make some great changes around the ecosystem. So yeah, this was the this was all of the slide about. Let's discuss about yeah, before going to the core architecture. I just want to make sure you guys are you know tuned in. You can ask doubts, like if you want to ask any general doubts regarding off-chain services. Yeah, you guys can have some doubts also, right? Cool. I think we'll discuss the core architecture. That's like very interesting, and we all know like how off-chain systems work. So that was the core reason I discussed off-chain services, because directly moving towards CRE doesn't make any sense, since it's very complicated to start with. But since Vansh has bridged us greatly with the orchestration part, so I can definitely feel some confidence in this, like we can directly dive in core architecture also. So yeah, let's move towards core architecture. CRE, think of CRE as uh, a simple analogy for CRE is it's nothing but a set of bundles of logics. Now what those bundles of logics are, those are nothing but execution pipelines of workflows. uh, Workflows are logic builds, the logic blocks of like Vansh has given the analogy about Lego. You can think CRE as a Lego set where workflows are the linear blocks arranged in a particular sequence of logic that matches your end goal, like what output you want from the CRE. You can have multiple outputs, multiple inputs, doesn't matter, but the sequence should be particularly the framework sequence should be uh, mandatorily followed. until and unless that the logic output you will get should be optimal, right? It has to be optimal. So we'll deal with how the sequence is to be kept. Yeah. So regarding workflows, I've given you a little idea. Workflows are executed across multiple Chainlink nodes within a decentralized Oracle network, aka DAWN, enabling coordinated off-chain computation and consensus. Yeah, so we are now entering into the core architecture of how CRE works. So, as I said, workflows were execution pipelines or the logic blocks, which you can either write in Golang or TypeScript, depending on the SDKs which is provided by CRE itself, which we are discussing. We are going to discuss in the last slide, I guess. Yeah. So, in the just a second. Yeah. So I have a diagram ready for you guys to visualize what Dawn is. Basically, Dawn stands for decentralized Oracle network. Uh, there can be there can be multiple Dawn networks in particular CRE instance you are developing. This is just a single instance of the Dawn to make you understand how what Dawn exactly contains and how wrappers work around these Dawns to support your CRE development. So yeah. Uh, so if you are a developer from if you have developed around native Chainlink, like if you have developed some systems like triggers or some data feeds or some push Oracle side integrations, you probably know OCR, right? OCR is nothing but a consensus protocol which is built in-house in chain with Chainlink, and it supports it is the basis layer of support for CRE also. Like CRE runs on top of OCR protocol only. So OCR protocol basically has a light consensus included in it, which again manages the node network, which is included in a Dawn. So a single Dawn instance contains like n number of nodes, which are configurable again. In CRE low level development, you can configure the number of nodes in a particular Dawn instance also, like how many nodes you actually want, and a P2P networking layer for those particular nodes to communicate with each other. Now, you might be asking like, why do we really require Dawn and these networking layers? Like these terms are familiar with L1 development, right? So why actually we need these concepts in orchestration, right? So the plain answer behind this is like Dawn actually helps us validate things in CRE. Like CRE, the specialty of CRE is everything which has the SDK involved in it, every logic which has SDK provided in it, it runs through Dawn network. And why it happens is because to verify things, to validate things, to get a median value of particular input value. Like suppose I think before yeah, so let's visualize it with the diagram itself. Suppose as I said, you are completely free to build any workflow, any logic, whichever your project requires around orchestration. So you just dump that logic in these workflows. Suppose these are the workflows, the real-time workflows which are engaging with CRA SDK, and you dump some logic in any language like Golang or TypeScript in this workflow. And what happens is in the while the time of compilation and in the execution runtime, these logic workflows will get compiled and these will be processed in the Dawn itself. Like Dawn is nothing but again collection of nodes. This is single Dawn instance, this is Dawn 2 instance, this is Dawn 3 instance. There can be number of instances of Dawn which are held by a leader Dawn. So this workflow suppose has some logic like if you're fetching some APIs from external providers, API providers, or if you're doing some RPC calls. So like the question arises like who is verifying those API calls? Who is aggregating those API calls? Like The real world scenario is, suppose you are fetching uh, price feeds from three different APIs. Suppose one of them is CoinGecko, the other one is Binance, the other one is like any take any Redstone maybe. Yeah. So, or API 3. So any Oracle service will give their own predicted aggregated price data feed to you at single instance. Like at one single timestamp, you will get one feed, right? So for three instances, you will get three different feeds, and those three different feeds can be different at different timestamps. Uh, like, are you guys able to you know tune in? Like, do you guys have any doubt regarding workflows and all? Because I think I'm moving a lot faster. Is the pace okay, right? Or should I reduce the pace? Okay, cool. So what I was saying is, if you have three APIs, so let me just explain you guys with the diagram itself. Like, so these are the three API instances. Uh, yeah, and API 1, oops, API 1, right? API 2, right? And API 3. So what happens is, at particular timestamp, these three APIs will give you different price value. Suppose you are fetching price for Ethereum at some block, at some timestamp, like any UTC timestamp, and you are getting a particular value. Suppose 3000, 3500, 3600. So these values are different, right? You want a single output out of this. So what's the solution? Like, how are we going to reduce to a single output which is truth? Again, it's not like the incorrect values are always sharded here. They are not taken into consideration. Only the median values are taken into consideration. So suppose API 1 gives you 3500, API 3 gives you 3500, but API 2 fails to give you the accurate value and it gives you 3400. So what aggregator does here is it actually catches the median value. Like the median value is 3500, right? Out of three nodes, two nodes have provided 3500. So the aggregation actually gives you the median value, and that median value is again validated through what we call is Dawn network. So yeah, that's the basic requirement of Dawn, where it reevaluates everything off chain. This all these instances happen completely off chain. Like there is no on chain interaction as of now. So we are completely discussing about off chain elements only. So this was just like the real time example about API, because it is relatively easier to understand compared to other instances, like different Oracle instances where you are fetching the liquidity thresholds or liquidity depth or any slippage execution value or any parameter, basic parameter. So that will just uh, it will just make us really hard to understand how the intrinsic actually median intrinsics actually work. But through API example, I think it's clear to you guys like how aggregation works, right? So yeah, cool. Yeah, so we were let's go through the workflow slide. If we actually want to discuss about workflows, there are just 3 points which I think we should remember about workflows, and we'll just move towards next concept. But before going, just I need to have a recap with you guys. Workflows are nothing but execution pipelines. You can dump any logic, any size of logic, and it's not mandatory that that particular logic should be connected to the framework. It can be any execution logic that doesn't require CRE interference as of that particular instance. So it's not mandatory that workflows should always be related to CRE, but yeah, it's like general practice that you should include handlers and adapters from CRE. So to make it like more readable and executable through the Dawn network. So if you want Dawn with network to get involved, you need to build with CRE, obviously. So yeah, uh, these were like the basic, the blurb about workflow level. I've actually divided architecture into three basic phases, like workflow phase. Next one we'll discuss is yeah, the runtime level. Yeah. So before like we have got some idea about workflows, next phase we should be discussing about runtime level. But before that, there are some limitations about workflows that I need to make clear, because these are not clearly mentioned in the docs. If you try out reading docs, some points are missing, like from the development point of view, they are still it's a new product, so they are still evolving around it. They are still developing a lot of things within themselves, but yeah, there are certain limitations to workflows, right? So let's just understand what limitations. The first limitation which we faced while developing our in-house product at Block was, um, basically, suppose this is the workflow A, workflow B, different, which serves different logics at different instances, CRE instances, and workflow A cannot directly communicate with workflow B. That was the first limitation. Like there is no compatibility between these two workflows to directly call any functions among themselves. Like workflow A cannot call any function from workflow B until and unless there is some conditions that project setup in very special case. We need to set up a project in such a way that we can leverage the SDK development style into making these workflows communicate or call each other. But yeah, again, that's not suggested at all. It's good for experimentation, but I think these two workflows can only communicate officially via on-chain, off-chain rates, which will discuss again, which we will discuss again in further particular iterations. So yeah, that was the first limitation. And second limitation is uh, workflows. As I said, workflows can have any logic, but if you want to make the workflow go through the dawn and get validated, you should always include the uh, capabilities from the SDKs, and these capability workflows will eventually be processed by capability dawn. Capability dawns are nothing but a special dawn especially hosted to serve and execute capability logic. So what are capability logics? Capability logics are nothing but logics like networking, logics like error handling, logics like risk management, which are integrated within CRA SDK to make the SDK more uh, look more generic and more adaptable. Because these systems are heavy, have heavy computation, are very complex at every level, so we need some risk management along with it. And I think that that really happens through networking also. Like networking is the underlying protocol for each of these layers handling their own tasks. So capabilities are like very 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 important in CRE. Each capability has its own task, and those capability workflows are always validated by capability dons only. Like no general don will ever verify that particular workflow or that particular logic. There are some dedicated capability dons which will verify that particular logic. So yeah, these were some limitations around workflows. um, yeah, so let's let's move towards the runtime level. Again, if you guys have any doubts, please, just raise the questions here, because I think having lateral communication will allow me to discuss various points, because in this time window I can't really explain everything to you guys. The SDK is like very vast, and yeah, but the issues I faced while development were like these communication through workflows and workflow limitations, which took time for me to really understand, because the documentation was also not clear on their part, since it's a new product. So I just my whole intention here was to minimize that latency between us devs, because it will save your time a lot. Like if I throw out some points from my side which I faced while developing this product, around this product, so it will eventually save you guys also like a lot of time, uh, since it's like waste of time to figure out how workflows communicate, right? um, as I said, like direct workflows cannot directly call each other, but they have to do some on-chain smart contract reads as a glue between different workflows. So smart contracts are, here comes that on-chain verification part, which I was talking before, that if smart contracts are glued between two different workflows, then this becomes like a whole system, right? So it's not completely off-chain also, and it's not completely on-chain also. It's like completely integrated with off-chain and on-chain. It's like a glue within those layers. Okay. Uh, why worry about each workflow communicating with each other when we can orchestrate logic that can be used for both workflows in a single workflow? Yeah. So this point, single workflows, like, see, if you have to, I have already talked about capability logic here. If you dump everything into a single workflow, you are not keeping the system modular enough. um, it happens that some part of your logic doesn't, you don't want to execute some part of your logic through dawn, right? So why just waste everything, or why just waste compute power into the uh, duplicate logic that you don't want to get verified through dawn? It doesn't make any sense, right? So keeping things modular, instead of single workflow, I think that's the better option here, even if it costs some little gas, because gas is like very cheaper nowadays, and it's like very, it takes very less gas to get the communication going through between workflows. So doesn't matter at all, like that is very negligible value. But yeah, you need to, I don't know, like the team from yeah, uh, how do I unmute?
Yeah, can you hear me?
Hello.
Hello, can you hear me?
Yeah, go on.
Okay, yeah. So, quick question. You said
Hmm.
keeping things modular. So,
Hmm.
is it because of the gas or if it is required?
Gas is the primary reason why you guys might be thinking to dump everything into single workflow. But there is even a deeper reason, that every single workflow, like there can be numerous workflows, because each workflow has its own logic stored in it. That logic has to be defined in a certain way in CRE that doesn't use the capabilities, like the networking capability or the dawn capability. It can be a simple backend logic which is a helper logic for other workflows. Like in that particular case, it's like worthless to dump that logic into a single workflow, right? We, at the end of the day, we make folder structures modular because we don't want everything to mix with different functions. Like some functions are totally uh, not required at the dawn level. right? And this is like real-time example is like if you are dealing with APIs, you do need DON verification over the APIs, right? But if you're not dealing with APIs, if you're just hosting some external server through another workflow, you don't need any DON validation there. It's just a functional server or a helper server that achieves the output. Like, yeah, I think, yeah, it makes sense. And this was a point that we initially discussed at Blok also. But yeah, like keeping a single workflow, not cool at all. Like, it's not preferred. So nice question. Yeah. Okay, so getting on the next part, runtime level. Yeah. So the workflow part also comes in under the runtime level execution. Runtime basically means that whatever workflows are having those logic stored, they are getting compiled and they're eventually giving you some output through execution, through prioritization, through default workflow sequence. So everything that part comes under runtime. So yeah, let's go through runtime. It manages the execution of individual tasks within a workflow, ensuring each step of the Oracle computation runs correctly. Like the single instance I have mentioned here is Oracle computation. So yeah, the runtime handles scheduling and coordination of workflow steps, so tasks are executed in the correct order across the network. Yeah. So scheduling and coordination, we should talk about these parts. Scheduling, again, this introduces triggering and cron. So CRE has inbuilt cron system and triggering system, which again services like Chainlink automation already had, but CRE adds an extra layer over everything, like a wrapper of verification and cryptographic verification, I must say, across all chains, all possible chains. So yeah, scheduling means cron and triggering part. Coordination is basically the runtime level itself is a coordination pipeline. It coordinates different workflows or different logic blocks around a particular sequence, which is again mentioned in a particular CRE file, .init file, which defines the sequence of workflows to be executed. So if you again like the question we had before asked is if you have a single workflow with all the logic dumped in a single workflow, this coordination will it will be useless. Like there are no different workflows defining different logics. A single workflow with multiple logics, there's no coordination at all. Like this layer totally fails there. So there might be some reverts in that case also. Like we haven't particularly experimented at that level, but I believe that there will be reverts from CRE side if we play with single workflow and have redundant logic within those workflows which are not actually required by CRE. So until and unless you keep it very CRE limited, it works well. But if you dump unnecessary logic into those workflows, I think that will cause definitely some problems. So yeah, the scheduling and coordination, reliability mechanisms such as retries, error handling, the RMN stuff, like risk management services, like totally. This is again handled by CRE inbuilt through the SDKs. You don't need to worry about these things. Yeah, so CRE nodes execute workflow steps deterministically across the network. So yeah, determinism is something we should talk about. It's very interesting. So yeah, this is the diagram again. Here you can see I have mentioned some elements like state A, state B, state C. Basically, CRE doesn't allow workflows to store the basic state of the workflow. Like there is no state of a workflow in CRE. But what if there were workflow states, like individual state of different workflows, like state A, state B, state C for different workflows A, B, C? So what problem it would have caused? Like this particular visualization will make you understand what problem it would have actually caused is, suppose the from let's talk about this workflow for instance. At some timestamp there is some input A, like we have already discussed about APIs, right? Suppose that input A is some API output from API handling, and that output is like, suppose that output is feeded to the dawn as an input A, plus there is some state, uh, like any state associated with that logic workflow, like for suppose state A, but at certain point of time, like when time changes at certain timestamp, that state becomes state B. So input A plus state B, suppose we are getting output A dash, like, right? So this is this plain algebraic expression for the input output uh, uh, what we can say relation. And suppose at certain different time step, the state A has first changed to state B, and then has changed to state C. So input A plus state C, again you will get something different output, like output A double dash, right? This is not same as previous output. So what happens in dawn is every node basically performs at a particular time instance the same logic which is executed in which is dumped in that workflow. Like it goes through every node, node 1, node 2, node 3, and they all compute those instances at same time step. But due to partial failures, like node starting failures or some delay in off-chain services, like there may be some relays in between underlying relays by Chainlink, which can cause some delays. There will be some differences in the inputs or in the states. So the determinism is gone completely. Like we always need determinism in CRE, right? So that's the very core reason that the states are not maintained by workflows. Like workflow is state free. There is no any state in workflow. Like you can't just you just can't directly uh, define a state of a workflow, right? The blockchains, like just take an example of any blockchain. Like any blockchain will have a state stored into it, but at certain, when the block builders build a block, the state actually changes from A to B, right? So this doesn't happen in workflows. Like they have to be deterministic. And why deterministic? Because they eventually want the median aggregation as an output. Median aggregation means the uh, more number of outputs which are correct, and the wrong outputs are automatically sharded by the dawn network. I hope that makes this point clear. Right. Yeah. Yeah, we kind of discuss these things at our meetings also, like, and we encountered these things, like I guess after 1 or 2 weeks, which like we actually didn't know workflows cannot call each other, but after a couple of weeks we found out that, and we pivoted to a different folder structure. So that was the basic reason I want to focus on those points, those pain points which we faced at our initial development stage. And it really will save a lot of time if you guys are really interested in developing around CRE, because these points are like very niche and very in depth. They you cannot simply understand it by reading the official docs or the repo. So yeah, that was my main intention to call this question. Yeah.
Right. Yeah. So when dealing with CRA, what's
Mhm.
the best real project that someone can really apply it to and get how it works perfectly?
uh, okay, so I was gonna share a sample project with you guys. Let me just is the screen visible?
Yeah, it's visible.
Yeah. So this is I've tried this instance of CRE with my own lending kind of protocol, but it's basically an MEV execution controlled execution environment, which is again based on CRE. I would say, like, do you guys know OEV? Like, OEV is particularly very a niche concept around MEVs. Like, MEV is like a huge concept, but OEV is like Oracle extractable value, are very niche concept in around MEVs, backrunning attacks. So I have developed an OEV optimizer around my own mock lending protocol. And this all is based, it's all based on CRE. Like, you can see capabilities, config files, the glue contracts which I was talking. Like, these contracts are on-chain contracts which act as a glue between these workflows. Like, these are the workflows. Let me show you. Yeah, these are the workflows, like detection workflow, distribution workflow, execution workflow. So this is like a very high level complex project. It requires various things to be integrated. Like, you can integrate graph to read away liquidation positions and work on those liquidation positions to extract possible OEV value. You can have any freedom. That's the real magic of option systems. Like, there is no any binding to you to remain integrated with CRE at all. Like, CRE is just a helper for you guys to validate things and get on-chain verification done with multi-chain extension. That's nothing but CRE. But everything rest is like your backend development, basic backend development. You have that freedom to integrate anything. It's an SDK. You can grow that SDK as much as you want. So yeah, this is the real-time example of how we can build around CRE. And yeah, these are the workflows. If I'll give the auction house concept, yeah, we are in the auction house. Yes. So this is the auction house contract, a glue contract, which again is at certain level. I have stubbed it, but yeah, like, we can see adapters, capabilities. I was talking about capabilities. Like, these are the capabilities around EVM. See, I'll give an example, like write report, right? Uh, the basic write function. These are all included in the SDK. If I'll show you the SDK, let me show you the SDK, right? Yeah. So let's go to CRE SDK Go. This is the Go SDK, by the way. There are two types of SDKs, Go SDK and TypeScript SDK. Go SDK is more reliable in distributed systems since Golang is preferred a lot of times. So we at Blok Capital have used Go SDK as a native SDK to develop around CRE, but you can also use TypeScript, so no problem in that. So yeah, in capabilities, let's see about scheduler. So yeah, trigger SDK Django. So this gives you the functionality around triggers, like different capability ID for different triggers. If configs any function, this is the core function. Yeah. So you can reuse these wrappers to build around cron triggers also. If we talk about EVM integrations, we can go to client SDK Django. Here you will get some wrappers around contract calling, logs, balance, estimate gas. So these are all helper functions for which is under capability itself. We can use those. EVM dot any capability function, you will get it. In networking, HTTP, suppose. Yeah, this one. So send requester, send request. This is the core function. Then you can handle that send request also. So yeah, this is the advantage of SDK, right? So the layout is given to you guys. You just need to extend it. If we move towards the core CRE part, the consensus aggregators, again, yeah, this is the important part. I'll show you the median aggregation also. Like, yeah, this is the yeah, this is the core median functions. So these functions basically help you to get the median aggregation out of various inputs, stateless inputs from the stateless workflows. So just import this file and call these functions, and you're ready to go. These are the consensus aggregation from tags. Like in the config itself, you need to define some tags, like which should be aggregated median wise and which should be aggregated normally. At that level also, they have given you the flexibility, right? So yeah, definitely worth checking out. So again, the important aspect about CRE I forgot to explain is, let me just get to the diagram. CRE basically, this is very important. This execution of CRE is usually asynchronous, right? Since we are dealing with APIs, Oracle feed updates, external migrators or relayers providing you data, this has to be asynchronous. It can't be just synchronous, right? The native system will definitely fail if it has set to synchronous execution. So natively CRE is asynchronous, but at certain points, like the dawn aggregation, it has to be synchronous because it has to listen to every node input. Until and unless all nodes get participated in that particular epoch round, it just cannot generate a report regarding any output, right? This has to be synchronous. So what I'll say is CRE is asynchronous in various ways, but also synchronous at certain points. This is very important. Like from development perspective, you should know these points. And again, these are not mentioned in the docs, but as you develop around CRE, you'll definitely understand what I'm talking about. So yeah, back to the game. Any doubts till now, like around aggregation, workflows, general execution environment? You can ask directly. I think that communication will, definitely, I'll not miss any point then, because since I'm having my own flow, I'll certainly miss some points. And if you guys want complete clarity around CRE, you should, have that two-way communication. So yep, looking forward to it. Let's have a 5-minute doubt session. If you guys have any doubts, please ask, or else we'll continue. Most of the part I have explained it to you guys. Like the core part is what I have explained right now. It is like most of the times you need to deal with workflows, the capabilities, and yeah, that's it. Like you don't need to configure the dawns. It is already configured, but if you do need to configure it, you need to go at some low level and define the dawn structure also at certain limitations, that too. So whatever, again, one point to add is whatever dawn you are using, it's basically a public dawn, a public network provided by Chainlink. So it doesn't cost you much. It costs you, like, to deploy, it will cost you some gas, but not much, like not like L1s. So since there are very less nodes involved, so yeah. Okay, cool. Let's go to the yeah. Yeah, this is already explained. Yep. Yeah, verifiability. Last but not least point around the core architecture. So we will again discuss some node level architecture. Like, let's start with the first point. Each Oracle node cryptographically signs the result it produces using its private key, creating a verifiable proof that the data or computation generated originated from a legitimate node in the network. So what it means is the signing basically, there is like a parent node or a master node which defines public keys to for on-chain verification. Like there are two types of verification: off-chain verification and on-chain verification. Off-chain verification often happens around dawn level, but on-chain verifications, as I said, there are some gluing contracts which require to orchestrate things between CRE. So within those contracts, like smart contracts always verifies the external feed. So whenever off-chain tries to reach to a smart contract, it will verify it using the public keys provided by the CRE itself. So these two are the cryptographic verifications that are happening at the same time. Yeah, results from multiple Oracle nodes are then aggregated using multi-node aggregation mechanisms. Again, multi-node aggregations, that means the median aggregation, which combines signed responses and help establish a consensus output rather than relying on a single node's result. So that centralization part is completely eliminated here using the node architecture and signed responses generating a single report. So yeah, that's like we are completely dealing with decentralized systems here. Along with the cryptographic proofs, it's submitted to verification contracts deployed on chain that validate the authenticity of node signatures and confirm that the required quorum of Oracle nodes participated. So yeah, this point explains the on-chain verification part, which happens through from the smart contract side via public key generated by the node, the head node or the parent node of that Dawn network. So every Dawn network has a head node, and there are different nodes which act as a slave nodes around that head node. So head node is someone who generates a report for that particular Dawn instance. Think of it like this. And yeah, smart contracts can securely trust off-chain computation results while maintaining decentralization. Yeah, so this is the summary of all points. Like we are talking about decentralization, trustlessness, containerized logic, execution and coordination all together in this runtime and verifiability in CRE sections. So like these points will definitely aggregate the every notion about CRE. Like it all will make sense when you think of these points all together. And yeah, like hope that makes sense. Yeah, if you guys have any doubt regarding verifiability or any basic Dawn level architecture, you can directly ask.
Yeah, I asked a question on. I wrote a question on the. Okay, I don't know if you. I
Oh, okay,
wrote a
okay.
question on the list.
Yeah,
So
yeah.
I was asking if there is any possibility of
Hmm.
rebuilding and submitted arbitrage to this with Chainlink with CRE. Like I said, that we combine both Flashplan and different decks. For instance, so every hour the workflow will utilize the logic from the smart contract
Hmm.
to figure out which decks has any arbitrage opportunity. Then it will borrow from the flash loan. Try to
Yeah,
utilize that opportunity.
yeah, definitely. Like arbitrage scenarios in within CREs is definitely possible. Like it's one of the best use cases. So you can definitely build a bot around arbitrages, basic arbitrages, or yield arbitrages for yield perspective. In that yield perspective, you can definitely try. I think it would be a great project to try out and see the capability of CRE, like how much it is capable of actually automating and orchestrating things. So from orchestration point of view, if you are working around yield projects, I hope like it will clear a lot of concepts around CRE. Yeah, definitely you can try that out. No problem in that. Cool. Just to clarify, Dawn is a decentralized network of servers which has consensus in them, right? Yeah, it's like decentralized network for computation capabilities. Yeah, Dawn is something which is a group of nodes. Simply think it as like that. Those nodes are independent nodes independent instances which aggregate, which take some inputs from a particular workflow and regulates it or process it and give a particular output. So Dawn is basically a group of nodes. You can think of it like that. And every Dawn has some ID, Dawn ID, which is recognized by the orchestrator within the CRE, underlying pipeline in the CRE, which recognizes Dawn and allots it to a workflow depending on the workflow capability. So Dawn is a special network of nodes. Yeah. Yep. Any other questions like around project, from project
And,
perspective? Yeah.
I think you didn't make mention of the CRE reading and writing
Uh,
smart contract.
yeah, EVM capabilities. Yeah, I already mentioned about EVM capabilities. It comes under the EVM capabilities only, read write options. So EVM write, EVM read. So basically, what I was saying is uh, the the contracts like these are basically the glue contracts between the workflows. Like different workflows will orchestrate their logic using these smart contracts. Like suppose for an example, like if the detection workflows depends on distribution workflow for some instance, and again this directly cannot call the functions from distribution workflow. So what it will do is it will go and it will use a smart contract hosted as a middleman, as a glue, and it will communicate with these contracts to detection workflows. So to do this particular functionality, it will use EVM write and EVM read kind of functions from SDK. So yeah, hope that clears you out. Yep. I think I have meant. Have I missed any question here? No. Yeah, looks cool. So yeah, any doubt?
I think no one has any doubt.
Yeah. Seems like that. I think you guys are little bored with the concept, but I really can't help it. Like I have added a lot of diagrams to make it look less complex, but CRE is not easy. Off-chain systems are sometimes very complicated than on-chain systems. Like a lot of like certain validations are not abstracted from the developer. It's kept for the developer to keep the flexibility. So it seems sometimes very overwhelming to deal with all those things. But I think those are important if you are building around off-chain systems. So yeah, like core uh, core perspectives I have already explained to you guys. So this is just basic the Dawn level interacting on chain, an aggregator contract for an instance, which uses single median report submission. So yeah. Um,
So I wanted to say something because I also did some experiments with the
mhm.
CRE, and I realized that I find it quite difficult to interacting the CRI with my front end. So it seems like there's no since it's still on development stage, there's no way you can be able to just like the way you interact your smart contract with your front end. I don't think they have that. They have that.
Yeah. Agree to that point. Yeah. The cross-chain, like the UX bridging is not really possible with front end for the CRE. But what I think is CRE is meant to be in the underlying tech in the backend systems. It's not built for something to query from front end and transfer it to the backend. I believe it's not optimal for that part, but mostly think CRE as a helper helper framework for you to uh, validate off-chain things on chain. Like this is the core use case of CRE. Don't try to mix CRE with the front end querying part. I don't think it's made for that part basically, but maybe it's still in the development process, so maybe they will think about that particular aspect also. Not sure about that, like how CRA will deal with front ends basically. Like personally, I'm not sure like what to answer to that question. Basically, they don't prefer any capability as of now for front end executions. Yeah, definitely. Yeah. So
So sorry, do CRE also read data from from the blockchain?
sorry, can you repeat?
Can CRE also read data from the blockchain?
Yeah, it definitely can read data from blockchain. Yeah. What I meant is from front end for front end integration, CRE is not very optimal. Um, like I have seen no projects which make CRE interact with complete front end setups. So I'm not sure about front end part, but yeah, it's definitely meant for blockchains. It's built for blockchain, so it will read and write data for blockchains also. Yeah, any more doubts? Yeah, I think last point which I really want to explain to you guys about intent-based execution. Uh, this is what actual hype around CRE was basically around intents. And what are intents? Suppose Vansh has already explained around some part around intents, so I'll just give you guys a recap about what intents are and how CRE can control those intent executions. So basically you are the user. So in traditional DeFi machines, what usually happens is you need to choose some execution patterns. Like suppose one execution pattern is proceed with cross-chain swap execution without aggregator, right? For some reason you don't want aggregator to get involved. You have to do it manually, since your swap amount is very large and aggregators can't handle those swap amounts like the traditional old systems used to do this stuff. So makes a lot of sense if you relate it with little older DeFi, not the modern DeFi. So suppose user wants to go with this option. Yeah, so what it has to do is it has to select a router or relay to do that cross-chain swap. Again, after that, as a user, you need to also verify the gas, liquidity, or the fees, external fees like protocol fees. And this all abstraction is not taken away from user, but it's kept for user. And user has to, verify all these things. But when intents were classified, like when intents were talked really, very in hype, or people really talked about intents were something like user just have to produce a certain signature or certain intent of what he has to do. And this all intent metadata payload intent payload is just offloaded to some off-chain execution engine, and that engine will execute all the parts. Like, and in this case, since we are discussing CRE at this level, this engine is nothing but CRE. Suppose that. So what CRE can do is CRE can promote a risk management system, a control execution system, validation, on-chain verification, simulations for better gas results, fees results, and extensions in its own ways, like adapters and all. So this was the entire intents. Like today's marketplaces around intents are based on this particular logic, that we are abstracting various functionalities from user, and we are automating those abstractions. So the best use case today, like the conclusion of the story is, end of the day, we are all getting along with orchestration through CRE. Like the best use case of CRE is orchestration, and orchestration has very different meanings for various particular tasks. In DeFi, it stands different, but in at blockchain level, it completely means different. It it includes different elements in L1s or cross chains, or in DeFi it includes relayers, routers. So it has its own meaning around each domain, but overall the thing is we know we need some controlled execution and validation on chain as well as off chain, and that's what CRE brings to the table. And yeah, this was the entire blurb around CRE I have made for you guys. um, yeah, so hope it all makes sense now. Yeah.
I still have I still have one question to ask. From yeah, from security perspective,
Mhm.
because I believe that as the if access is given to any user to call the workflow, I think that's I think the way series is developed is not developed for just for workflow. It's designed for like an admin to be able to utilize the workflow. If not, anybody can just go and
Yeah.
see a lot of that because of
Regarding access control, basically what I think here is you initially try to develop the product in a way that no one has a single control on it. Like suppose there is this central entity which controls a particular off-chain engine that helps another protocol grow or another protocol lose less value. So basically it's again centralized, so it has access to that engine. It is owned by that centralized community or group of people. So regarding access control, workflows are independent. First of all, if we orchestrate workflows around in a way that they cannot be tampered with, I think that's where the actual modular system and the actual development comes into play, where we can you know uh, put access control, a certain kind of access control around workflows. And that's the reason we never intended to take orchestration in at the level of DAO. Like DAO is completely kept separate for this reason. We don't want to indulge those particular parameters from workflows into the DAO, like, because again that access control issue it has. So right now I prefer to develop the system in a way that it doesn't require access control anymore. It is just an automating pipeline which automates on triggers and works with the smart contracts. Like smart contracts are the originators here, not the off-chain system. Off-chain system will work based on the smart contracts. That's the very important thing we need to consider here, because it's not vice versa. Like what question you was asking is basically what if workflows can be triggered by anyone, right? But I think if we orchestrate it in a way that if smart contracts are triggering those workflows, that's very crucial. Like that's the crucial part here. The everything we have discussed comes to a conclusion that it is dependent on the on-chain systems. Off-chain systems always help on-chain systems to carry out the operations, not the other way around. That's the very core reason off-chain systems are developed today. So if you understand that particular point, I think you'll understand what CRA actually means. And yeah, great question again.